Okay, so this is lesson 9, intermolecular forces. Your objectives will be to differentiate between hydrogen bonds, dipole-dipole, and London dispersion forces, and explain how the properties of melting point, boiling point, and vapor pressure relate to attractive strength or attractive force strength. During the video, I want you to write down at least 2 questions that you have about the concepts. You will be required to share your questions in class the next day. So lesson 9, intermolecular forces, also known as IMFs or IMAFs. Okay, intermolecular attractive forces. Only in covalent molecules, never ionic compounds. They are weak forces, generally, that act between molecules, that hold molecules to each other. Okay, only exist in the gaseous and liquid states. So if we think about water, okay, H2O is made up of millions of molecules, right? In the liquid phase, molecules will be somewhat attracted to each other. Okay, so let's say we have water, okay, we have H2O and H2O and somewhat fluid, and I will demonstrate this in class, but it can still flow in the liquid state. In the gaseous state, these water molecules would be very far apart, okay, and the attractive forces would be weaker because it wouldn't be, they would be spread out more. So they're called weak forces because they are much weaker than chemical bonds, which occur in covalent bonds and ionic bonds. So we have to note that IMFs are not bonds. They are just attractive forces between covalent molecules only. Okay, so remember that IMFs occur between molecules, whereas bonding occurs within molecules, within it. So here's hydrochloric acid, or a molecule of hydrogen chloride, we should say. The bond here is a covalent bond between 2 nonmetals, very, very strong, but the intermolecular attraction is considered overall weak. Okay, these are molecules because they are made up of covalent bonds, and the attraction between the 2 molecules is not as strong as the bond within the 2 elements in the compound. All right, so what I would like you to do is go to this link to look at an animation of hydrogen bonds, and then once you have done that, you can continue with your notes. And remember, IMFs are not bonds. So let's look at the first type of IMF, and IMFs are caused by molecular polarity. So it is very important to understand concepts from the previous lesson in order to determine what type of IMF we're going to be looking at. So the first one is called a London dispersion force, or LDF. They're the weakest of all of the IMFs, only important for nonpolar molecules. And what we want to say is that more electrons will equal greater London dispersion forces, LDFs. All right, so the electron-electron repulsion creates brief dipoles, and dipoles are charges or partial charges on the atoms in the molecule. Okay, so again, check out this animation here. Go to this link, and we're going to add some more information. Remember, we're looking at nonpolar molecules, so remember SNAP, right? Nonpolar would mean that there are 2 or more lines of symmetry in the shape, if we're looking at this shape. They will have low melting points and boiling points, and I'm abbreviating that for you. And these will have good vapor pressure, which means that it has a high ability to evaporate. Okay. Next type of IMF would be the dipole or the dipole-dipole moment. Molecules such as hydrochloric acid or HCl have both positive and negative ends, which are poles. Okay, hydrogen bonded to chlorine. Chlorine has a higher electronegativity value, so this would give it a partial, okay, and the symbol looks like this, a partial negative charge because it's more electronegative, and then therefore the opposite end would be a partial positive, obviously because they have to attract each other in a bond, opposites attract. And these two poles are called dipoles. All right, di meaning two poles. Results from an unequal or asymmetrical sharing of electrons. The dipole-dipole is two molecules with permanent dipoles, and they are attracted to one another temporarily. And the dipole moment will measure the strength of the dipole within a molecule, which tells us the polarity. Okay? The greater the difference in electronegativity between the atoms, the greater the polarity or the dipole moment. This is very important. The higher the dipole moment, the stronger the intermolecular force. The stronger the intermolecular force is, the higher the melting point and the boiling point. Here's a little chem movie. Check this out. When you are finished completing your notes, we're going to add some information here. So for molecules that have dipole forces, they are moderate in strength. Remember, it depends on the electronegativity difference between the atoms. They are fair, or they have fair melting points and boiling points, okay, kind of in between, moderate, and they have fair vapor pressure. Which means they moderately evaporate. Finally, the last type of force is called a hydrogen bond attractive force. Specific type of dipole, it is a dipole interaction. Okay, in a polar bond, hydrogen is basically reduced to a bare proton with almost no atomic radius. Therefore, it will be the strongest of all IMFs by far. Only occur in molecules containing hydrogen and oxygen. Nitrogen, and, or I should say, fluorine. And finally, the last animation that I'd like you to check out right here. So please go to this link as soon as you get a chance. So lastly, we're going to sum this all up, and we're going to look at a little flow chart, and you do need to put this at the end of your notes somewhere. So first you're going to look at the formula. Step number 1. Look at the formula. If it is made up of a metal and a nonmetal, it's going to be ionic. If it's made of nonmetal atoms only, it's molecular. If you see a symbol of a metal, it's considered metallic. And if you see carbon or silicon oxide, or dioxide I should say, which is quartz, then they're considered network solids, which we didn't really talk about completely in detail, but just know that we're talking about graphite, diamonds, quartz, okay? And then let's go down where we split from molecular compounds here. If there are two or more lines of symmetry, so we're going to look at the shape of it, it's going to be a nonpolar molecule. And if there's only one line of symmetry, you have a polar molecule. Remember, if we're looking at bonds, okay, electronegativity differences will be 0 to 1.7 for covalent and greater than 1.7 for ionic. That's when we're talking about the bonds. Remember, forces are not the same thing as bonds, and we're also saying that the electronegativity differences are a little different when we're talking about the polarity on the molecule as well. Okay, so one line of symmetry, polar molecule, electronegativity difference is greater than 0.5. Polar molecules will have dipole moments, either hydrogen bonds, bond forces, or dipole intermolecular attractive forces. Both are very strong, or considered strong, but the hydrogen bonds are the strongest out of the three. Over here we have London dispersion, which are weak, the weakest of all three of them. Nonpolar molecules will have low melting points, low boiling points, high vapor pressure. These are all properties that you need to know. And also, under polar molecules, they are responsible for the unusually high melting point and boiling point of water. Okay, so these hydrogen bonds between the hydrogen and the oxygen, because the attractive forces are so strong, it requires a lot of heat to melt something, or a lot of heat to boil something as well. Okay, and that's why water is a very unique substance. The dipole attractive forces are strong. Moderate melting and boiling points, or medium, fair, however you want to say it. And the strength of the IMF increases as the electronegativity difference increases as well. So that sums up everything in this lesson. Please do not forget to write down at least your 2 questions for class tomorrow, and we will go over whatever you would like for this entire unit, because we will begin reviewing.